Now you may be asking, what is the relation between power, work, and time? Firstly, we start with the power. As you know by now, the power is the rate of doing work. How would you represent that mathematically? P equals W over delta T. And that means as well P equal delta E over delta T. And in many cases, we hear that the power is being measured by the horsepower. And the history for the horsepower, back in time where the scientist Watts was doing his research, all the applications focused basically on moving the water pumps based on horses. So the horses will be rolling around axle, and that axle will transfer the power to the pump that's doing a rotational motion that will pull the water in buckets to the surface. And that was like the basic style of a water pump. When Watts came out with the concept of power, he was struggling what unit he should represent for power. And by that time he said, well, now we're using horses to pull that amount of power. Watts, by the time he invented his own version of a steam engine, but he couldn't tell if this engine is stronger than the horse or not, so he compared it with how much the horse can transfer water through the pump. And when he put his steam engine instead of the horse, then he can decide that steam engine equals how many horses of work. So from that time until today, surprisingly, we are using horsepower to represent the work versus time. And we are using that until today in the automotive industry, which is sad. We should be using more modern units, but that's the history for it. So the HP or horsepower lived for so long. Now, after that time, the power given the unit of watt as a recognition for James Watt, who contributed a lot to the physics and to the field of power transfer. And using the equation of power, we can see the power output of 1 watt results with 1 joule of work that is done per second. So 1 watt equal 1 joule over 1 second. So 1 watt equal 1 joule per second. Efficiency is really a wide term. Efficiency means how good is that thing running. Depending on the field that you're talking about, efficiency definition can be the same but can vary in the philosophy in the same time. So when you say that energy efficiency, it means energy output over energy input, or the ratio of energy out over the energy in. In this case, you are saying how much energy did I put versus how much energy did it go out. So when I have a lamp, we connect it to a battery. Now, how much energy out of the battery gone to the lamp versus how much energy really being used to make light? That's how efficient is that lamp. And we know in real life, the lamp will not consume all the energy in. Some of the energy out will be wasted through heat and through friction and all other physical limitation on the energy and on the system. The efficiency for the power is power output, P out, over power input, P in. So the efficiency is the ratio of the energy output to the energy input of the system. And as I said, efficiency doesn't really relate only to energy, it relates to anything in life. If you can say about a car, how efficient is that car? If you're thinking about energy-wise or gas consumption, you can say, okay, I put in it 100 liters of gas and it delivers me this much and this much. So the more the vehicle convert that gas into pure motion, the more efficient that vehicle is, which means it's more economical. Let's take an example on power, work, and time. We have an elevator and its occupants have a mass of 1,300 kilograms. The elevator motors lift the elevator to 12 feet floor, a distance of 40 meters in 75 seconds. What is the power output of the elevator? We know that the power delta EP over delta T. That's one way of expressing the power. We have the mass, we have gravitational acceleration, we have delta H, the height, we have delta T, and we have the input power. Now we change delta EP into mg delta H over delta T, and that would give you 1.3 by 10 to the power 3 by 9.8 by 40 over 75 would give you 6.8 by 10 to the power of 3 watts or joules per second. Why we use here delta EP? We know that P equal delta E over delta T. The system here is mainly regarding to the potential energy. When he raised up 40 meters, that means the potential energy is getting higher, and at this point the kinetic energy is 0. So you need to be considerate what kind of system you are solving in this case. Now for the part B of the problem, what is the efficiency of the system if the motor must generate 9.4 kilowatts of power to do the specific work? We know that efficiency regarding power equals power out over power in. Power in is given, and power out equals from here 6.8 by 10 to the power 3. So 6.8 over 9.4 would give you 0.724.